viewers, I am Dr. Mala Das Sharma, retired professor of St. Pius 10th Degree and PG College for Women, Hyderabad. Welcome to my channel Chemphilic. Let's start 51 episode of Teaching Chemistry through Riddle. Here is our riddle number 51, which goes like this. X is a reaction intermediate formed in a particular type of reaction Y of aromatic compounds. The reaction Y also proceeds by another mechanism where a complex intermediate is formed under a certain condition. The rate determining step of these two reaction paths are opposite to each other. X is highly unstable, but aromaticity is retained in the benzene ring of this intermediate. In presence of other substituents in the aromatic ring, more than one products of different proportion can be formed from the intermediate X. This intermediate is trapped by the conjugated diene in Diels-Alder reaction. So, this is riddle number 51. Now, let's see the question. Primary question or first question is, what are X and Y? The answer is X, benzyne intermediate, Y, nucleophilic aromatic substitution reaction. Now the other questions are, second question, from the mechanistic path, show that the rate determining steps of the two reaction paths are as mentioned in the riddle are opposite to each other. Third question, under what condition reaction Y follows the different path where intermediate X does not form? State few examples. Fourth question, why X is highly unstable? Fifth question, how aromaticity is retained in the benzene ring of benzyne intermediate? Sixth question, in presence of other substituents in the aromatic ring, more than one products of different proportion can be formed from the intermediate X. Explain the reason with examples. Seventh question, give example of Diels-Alder reaction with benzyne intermediate. Now, let's see the answer. Second question was, from the mechanistic path, show that the rate determining steps of the two reaction paths are opposite to each other. Let's see the first reaction path, which is addition-elimination reaction mechanism. And here, what you observe that first step is the addition, where nucleophile attack at the position of this benzene ring where the leaving group is attached, and this carbanion is formed, and this carbanion is stabilized by resonance, and this complex carbanion is known as the Meitner-Heimer complex. And then what happened? This leaving group leaves and we get the final product. And this is the elimination. This is the first step. This is the slow step. That is the rate determining step. Now, in second mechanism, that is known as the elimination addition mechanism, here the first step and rate determining step is the elimination, where the nucleophile takes the beta hydrogen atom in the sense with respect to the leaving group, this ortho position, that is also the beta position. The hydrogen atom attached to this beta carbon atom is taken up by the nucleophile, and then this carbanion is formed, and then this carbanion forms a benzyne intermediate, and the leaving group leaves. So this is the rate determining step, which is consisting of deprotonation and then the loss of leaving group. Okay. And next what happens? Now when this benzyne intermediate is formed, then again the nucleophile, it can attack either this position or this position. If it attacks this position, then the bonded electron pair shifted here, then the carbanion is formed, and then this carbanion easily takes the proton and gives the final product. So here what we have observed, that in the first reaction mechanism, addition of nucleophile is the rate determining step, and in the second mechanism, elimination of the leaving group is the rate determining step. Though it is consisting of two steps, one is deprotonation, one is loss of leaving group. And it depends which one will be actual rate determining step. That will depends on the halogen, which I discussed in my previous video. So in these two mechanisms, these rate determining steps are just opposite to each other. One is addition, another one is elimination. Now the third question. Under what condition reaction Y follows the different path where intermediate X does not form? That means benzyne intermediate does not form. State few examples. So, in presence of the electron withdrawing group in the benzene ring, the reaction proceeds through the addition-elimination mechanism. And the presence of the electron withdrawing group is mandatory for the reaction to occur through this addition-elimination mechanism or through the formation of Meissner-Heimer complex. Now let's see the example. See here, this is the leaving group and the para position nitro is present, that is nitro group, which is strong electron withdrawing group. So when it is treated with this reagent, then what will happen? This chlorine will be replaced by or substituted by the OH group. Okay, and we will get para-nitrophenol. Here what happened, when this carbanion is formed, as we have seen that in Meissner-Heimer complex, carbanion is formed which is stabilized by resonance, and that carbanion is much more stabilized by the resonance participation with the nitro group. That means this electron withdrawing nitro group stabilizes the carbanion through resonance participation, and the reaction follows this path. Now second example, see here nitro groups, similar compound, but nitro group is present in the meta position. When it is in the meta position, then it cannot stabilize this carbanion by resonance participation. So carbanion is not stabilized by resonance participation. In that case, here the reaction does not occur. Now third example, see this one. Here, this is the electron withdrawing group and the same leaving group is present ortho position to this nitro group and para position to this nitro group. Now, which chlorine will be substituted by the nucleophile? Now, when it is in the ortho position, that means this chlorine which is in the ortho position, in that case, carbanion will be stabilized by resonance participation with the nitro group. But when it is in the meta position, it will not be stabilized. That means this chlorine will be substituted by the nucleophile and you will get this product. Now next example here. So here this is the electron withdrawing group and there are two leaving group. One is meta position, that is fluorine, and one is bromine, that is in the para position. Though fluorine is better leaving group in this case, that is in nucleophilic aromatic substitution, but here bromine will be substituted by the nucleophile because same reason, it is in the para position. So the carbanion which is formed, what you have observed in the Meissner-Heimer complex, that will be more stabilized by resonance participation with the nitro group. So this will be the product. Now fifth example, here this is one interesting example. Now here also para position electron withdrawing group. So this chlorine will be substituted by here sulfide. This is S di-negative, S -2. So this sulfide di-negative will attack here. Then also it will have one more negative charge. Then what will happen? Immediately it will join with this compound, another molecule. Then you will get this product. And when it is oxidized by nitric acid, we will get this product which is para-nitrodiphenyl sulfone. Now sixth example, see here. Here also para-chloronitrobenzene, that is nitro group in the para position. Now the reagent is aqueous sodium bicarbonate solution. Then what will be the substituent? That means chlorine will be substituted by which nucleophile? So it is sodium bicarbonate, but after salt hydrolysis, it will produce the OH minus ion. So sodium hydroxide and carbonic acid, that is carbon dioxide plus water, will be there. So finally, this chlorine will be substituted by OH. So this is the product, that is para-nitrophenol. Seventh example. Here, so this is the electron withdrawing group, that is the aldehyde group. Okay. Now, this leaving group is present with respect to this aldehyde group here in the meta position, para position, again meta position. So, when it is in the meta position, this electron withdrawing group, then we have observed that carbonyl is not stabilized by the resonance participation, and moreover, here what happens, here this aldehyde group cannot stabilize the carbonyl by resonance participation when the leaving group is in the meta position. So therefore, this para position fluorine will be substituted. So we will get this product. Now this is another example. Here, substitution will occur here only, no problem. But look at here, in this molecule, this nitrogen atom also has lone pair of electron and oxygen also has lone pair of electron. Then, through the lone pair, which atom will attack? This nucleophilic attack will take place by which atom? Nitrogen or oxygen? We know that oxygen is more electronegative than nitrogen. So comparatively, it does not have more tendency to lose the electron, to share the electron. So attack will take place by the lone pair of electron of this nitrogen, and the product will be this one. Now fourth question, why X is highly unstable? Now look at here, in benzyne, this sigma bond in the ring between the carbon-carbon, these are formed by the sp2 hybrid orbital. We know that in benzene, carbon undergoes sp2 hybridization. And this p orbital of each carbon atom, which is perpendicular to the ring, they overlap both the direction sidewise and form the delocalized or continuous pi electron cloud. Now this in benzyne, this second pi bond, it is formed by the overlapping of the sp2 hybrid orbital of these two carbon atom. Okay. So now these sp2 hybrid orbitals, we have seen that carbonyl is in the, that is negative charge is in the sp2 hybrid orbital, and then these sp2 hybrid orbitals, they are 120 degree, means angle between them is 120 degree, but when they are forced to form this second pi bond, then this angle has to be changed. That means in this intermediate there is a lot of angular strain, angle strain. So it is unstable. So triple bond is formed by the overlapping of sp2 hybrid orbitals of two carbon atom. Lots of angle strain is present. Hence benzyne is highly unstable. Now fifth question. How aromaticity is retained in the benzene ring of the intermediate? Here, see, in this benzyne, all this continuous pi electron cloud, this is not disturbed because pi electrons are only, these p orbitals are already filled with one electron. They overlap sidewise and form the continuous pi electron cloud. Okay. And this already just now we have seen, this is formed by the overlapping of the sp2 hybrid orbital. So inside the ring, this continuous pi electron cloud is present and 6 electron, that is 4n plus 2 or Huckel's rule is obeyed. That means 4n plus 2 pi electron is present. So this aromaticity is not destroyed in the ring of this benzyne. Now sixth question. In presence of other substituents in the aromatic ring, more than one products of different proportion can be formed from this intermediate, that means that intermediate X. Explain the reason with examples. Now we'll take the example. So first example, this is para-chlorotoluene. Here electron releasing group, so no question of this addition elimination mechanism. It will proceed to the elimination addition mechanism or through the benzyne intermediate formation. Okay. Now here this is the benzyne. Now when we have seen the mechanism, when this benzyne is formed, then if the nucleophile attack here the negative charge will form. Okay. Now this methyl group is electron releasing group. It releases electron by the plus I effect. So when it is releases electron, then it will localize this carbanion more. That means it will destabilize the carbanion. So if the negative charge is far away, this destabilization of the carbanion will be less. So negative charge preferably form here. That means nucleophile will attack here. Then what will be the product? Product will be this one. This is the major product. Nucleophile will attack here and carbanion will form here, and when the nucleophile attack, that will be the minor product. So this is the major product. And this, to some extent, this product also will form as minor product. Now I'll take the second example. Here you see. Here this is the benzyne. Now, and this methyl group, this is electron releasing group. Through plus I effect, it will destabilize the carbanion. So if the negative charge is formed here, then it will be more localized, that means more destabilized. That means negative charge will form preferably here. So the nucleophile will be here. That means ortho product will get. And see here one more case. Now we consider this way. This is the benzyne. Now here, if the negative charge is here, then it will be comparatively close to this methyl group. It will be comparatively more localized, less stable. So if the negative charge forms here, that negative charge will be comparatively more stable. So if the negative charge form here means that nucleophile will attack here. Okay. So nucleophile is can attack here, it can attack here, and for both the cases, here also on product, it may attack here also, that as a minor product. So we will get a combination of all three products, that is orthomethylphenol, metamethylphenol and paramethylphenol. Now third example. Here you see, this is the leaving group, ortho position, electron releasing, methyl group is here. Then this is the benzyne. Now, if negative charge comes here, that will be more destabilized by the plus I effect. If the negative charge here comes here or forms here, comparatively it will be more stable. So negative charge will form here. That means nucleophile will come here. So what will be the product? So of course these two products will be formed, but the major product will be we cannot say any one will be the major product, because major product we can consider it as when this nucleophile is here, that means this product. But here another problem is there. When the nucleophile is coming here, because in ortho position bulky methyl group is there, some steric hindrance operates. So we will get these two products with no strong preference, means percentage will be close. Now fourth example, this one. Here, this is the benzyne. Now this CF3, this is strong electron withdrawing, but not by this resonance effect, by only the minus I effect. So when it is strong electron withdrawing, so this minus I effect, it operates like this. So here the effect will be more. So if the negative charge forms here, that will be more delocalized or stabilized by this group. So if the negative charge forms here, then nucleophile will come here. Then what will be the product? Say nucleophile comes here. Another product, of course, nucleophile will come here. But this is the major product. Now coming to fifth example. Now see here. Here also same groups but in the ortho position. So when it is in the ortho position, then what will happen? Then the only product, because here the benzyne will be formed here. The benzyne will form here. The negative charge, if it forms here, that will be much more stabilized or because of the delocalization. Why delocalized? Not localized because of the strong minus I effect of 3 fluorine atom. So negative charge almost it will form here only. If the negative charge forms here, then this nucleophile will attack here. So this will be the only product. Now 6th example. See here. Methoxy group, it actually electron releasing group in the sense it releases electron ortho and para position by plus M effect, but it has strong minus I effect. That means it withdraws electron by minus I effect. And in case of benzyne intermediate, we consider the inductive effect. Okay? Now from here, this is the benzyne is formed, and plus I effect will be more pronounced here. Minus I effect will be more pronounced here. So through this minus I effect, if the negative charge forms here, that will be more delocalized, that means more stable. So preferably negative charge will form here. So the nucleophile will come here preferably. Then the product will be this one. Nucleophile will come in this meta position, that is the major product. Now, next, similar things, they are in the meta position. Now, here also, this is the benzyne. Now, the negative charge forms here, that will be more stabilized by the minus I effect of methoxy group, because this negative charge will be more delocalized here. And then, what will happen? Then the nucleophile will attack here in the major product. So, major product will be this one. Now, example number 8. This is another interesting example. Now, here what happens? See, when you are giving the nucleophile will take this proton, okay, and this leaving group leaves. Then, this benzyne intermediate is formed. Now what happened? This lone pair of electron of nitrogen, this attacks this nearest. That means compared to this one, this is nearby. This attacks this carbon atom and this bonded electron pair shifted to form the carbon atom. So this is the situation. And then the final product will be this one. Now, 7th question. Give example of Diels-Alder reaction with this intermediate. This intermediate means benzyne intermediate. Now, benzyne intermediate is trapped by the conjugated diene in Diels-Alder reaction. Okay. So, Diels-Alder reaction we have seen, this is the reaction of conjugated diene with a dieno5. That is the multiple bonded compound. Now, here with benzyne mechanism, when this dienophile, that is conjugated diene is when this conjugated diene is added to the medium, then this product is isolated. That means benzyne intermediate is trapped by this conjugated diene. Okay, how this Diels-Alder reaction occurs? Here, this pi bond breaks, and this one electron and this second pi bond, one electron, they form a bond between these two carbon. And similarly, this pi bond breaks, this one electron and this one electron form a bond between them, and the remaining one electron, they form a bond, pi bond here. So it just join. So this will be the structure, and this carbon join with this carbon join with this carbon, and in this carbon and in this carbon, that is here this carbon and this carbon, this both are attached with this oxygen. That means this is the product. So, this reaction can be considered as the evidence for the formation of benzyne intermediate. So, this is all about today's discussion. Thank you.